Welcome to my channel. Today, in this session, let us discuss about the asynchronous counter. So, already we have discussed about the combination logic circuit and we also seen about the sequential circuits. In sequential circuits, we have discussed about the flip-flops. Now, we are going to discuss about the asynchronous counter. The asynchronous counter is the counter refers to as asynchronous is that do not occur in the same time. That means the switching does not take place at the same time. The counter operation asynchronous means the clock pulses are not directly connected to the C input. C input is nothing but that is not connected to the clock input of each flip-flop here, which is used for counting, right? Here we are going to discuss about the 2-bit counter, and if either 2-bit counter or a 3-bit counter, 4-bit counter or 5-bit counter, anything else is decided by the 2 power n case. Okay, and the 2-bit counter connected to the asynchronous operation is given by the figure below. And here, to explain the 2-bit counter, we have taken two different types of flip-flop and named as flip-flop A and flip-flop B. Here, the flip-flop A and B is provided by the JK flip-flop, and already we have discussed about the JK flip-flop. In JK flip-flop, if both inputs are high, automatically it toggles, right? In addition to the inputs J and K, here it is also given us and clock input. The clock is directly given provided to only the flip-flop A and not to the flip-flop B. So, such arrangement is known as the asynchronous, right? So, this is discussed at the early point itself. That is, asynchronous refers to that do not occur in the same time. That means switching does not occur in the same time. Here, for the 2-bit counter, two different flip-flops are taken. The clock is provided to only the one in flip-flop. The output of the first flip-flop is fed at the clock input of the second flip-flop, and the counter bit 2 power 2 bit is decided by nothing but 2 power n states, right? If n is equal to 2, it is known as it reads 4 states. If n is equal to 3, it reads the next 8 states, right? Depending upon the n, the number of states in which the counter counts is decided. And here we have taken a JK flip-flop, two different JK flip-flop in which the J and K inputs are connected to the high input. We already know that the truth table of JK flip-flop, if both inputs are high, automatically the flip-flop toggles. So the input is provided to the clock here, and the output of the first flip-flop is provided as the input of the second flip-flop, right? And coming to the first case, we are going to discuss about the same circuit diagram in the next cases. That means already we have said that here the clock input is given to the flip-flop A, and in which the second stage of the flip-flop B is triggered using the output of QA bar of first flip-flop, right? And output of first flip-flop A changes its state when the positive going edge of each clock pulse, but flip-flop B changes only due to the QA bar. That means by providing the clock pulse, this is the clock pulse. So it for the first cycle of the pulse, it changes the output. Coming to the first case, the clock pulse is given, and for the first cycle, the counter counts, and it has a T on state, and this is the T off state. Okay, for the second cycle, then the counter automatically tends to off. Right, that means the first stage of the flip flop tends to off. For the positive edge, there will be an triggering. So
For the positive edge, for this complete cycle, QA bar is this, QA bar output is this, and at this stage, the flip-flop B starts to trigger and it starts to count. So, if in the asynchronous counter, there is an inherent propagation delay, and also the transition of flip-flop A and the triggering of two flip-flop can be never happen simultaneously. This is the main difference in between the asynchronous counter and the synchronous counter, right? Whenever we are providing a positive triggering edge clock pulse, it automatically the counter triggers and starts to count. And the output of the first flip-flop is given as the output of the second flip-flop. And automatically, when the positive edges reaches to the second flip-flop, it also start to change its state, right? And this clock or the timing diagram is explained with the different states of the 2-bit counter, right? So initially, since it is a 2-bit counter, we have 2 power n states. That means n is equal to 2. That means 2 raised to 2, which is equal to 4 straight. For provided initial 0 clock pulse, we have an output QA is equal to 0, QB is equal to 0. For the next pulse or the first pulse, we have the QA output 0 and the QB output 0. Since QA output is high, we have an QA bar output as 0. If QA bar is high, then only we have an triggering in the second flip-flop, right? And next, for the second clock pulse, the QB is high and QA output is low. If QA is low, automatically QA bar is high. So this is provided in the timing diagram, right? So for the positive first pulse, it is high and QB is low, and the next pulse QA is low and QB is high, and automatically in this from the next cycle the second flip flop starts to count. And here, for the provided clock pulses, the counter counts in the case of binary counting. That means 0, 0, 0, 1, 1, 0, 1, 1. Right? So 0, 0, we know the decimal equivalent is 0. 0 is nothing but the decimal equivalent is 1. 1, 0 it is 2. 1, 1 which is equal to 3. So this asynchronous counter can also be set as the binary counter, right? And it counts up to the 3 clock pulses. As we have discussed earlier, this it counts up to the 3 clock pulse, and it recycles. This is the term in the case of asynchronous. Recycling is nothing but it refers to the transition of counter from its final state to its original state. That means it transit from its final state to original state. That means for the next clock pulse, automatically the counter resets. And for the provided next clock pulse, the counting starts. Right? So this is the general explanation regarding to the asynchronous counter. And this asynchronous counter is nothing but a 2-bit count. Right? Similarly, here we have discussed a 2-bit counter. If you need a 3-bit counter, it depends upon the number of 2 power n states, right? If it is 2 power 3, we have 8 states, right? And the and the depending upon the clock pulse, we decides of number of flip flops we needed, and the clock is provided to the first stage of the flip flop, and the output of the first stage is fed to the second stage, and the second stage output is fed to the third stage, right? So with this discussion, we have discussed a sequential circuit with the with the help of flip-flop, and the sequential circuit here we discussed is nothing but a asynchronous counter. In the next session, let us discuss something about the shift registers, counters, etc. If you like this video, like, share, and subscribe. Thank you.